So I always like to start out with a little bit of interaction with the audience, especially early in the morning, get your blood circulating a little bit. I love acronyms, right? You just heard one for rapid. And of course, SME, everyone knows what SME used to stand for, right? The Society of Manufacturing Engineers. We changed that name to be just SME because it's really more than just manufacturing engineers, although they're really, really important, but it's everyone that's involved in manufacturing. So those of you who are not familiar with SME, please check us out on the website, because I tell you, it is the place to connect and learn about things related to manufacturing, especially 3D printing, additive manufacturing. So that's two acronyms already. But now, how many of you have heard of NNMI? NNMI. Every time I ask this question, I'm amazed at how few people have heard of that. So the National Network of Manufacturing Innovation, it's happening. Congress passed a bill in 2014 called RAMI, another acronym, Revitalize American Manufacturing and Innovation. And that made this network official. So now there are 8 institutes scattered around the country, each institute focused on a unique area of manufacturing technology. The very first institute, take a guess which one was the very first institute. What technology area did the US government decide to stand up the first institute? Additive manufacturing. I'm involved with an institute in Chicago. We were the third or fourth. There were 2 announced on the same day, so you can figure out which one we were. One of those 3, either the third or fourth. And our institute is focused on digital manufacturing and design. So we're called DMDII, another acronym, Digital Manufacturing and Design Innovation Institute. And we've got 3 technology thrust areas. One of them is in advanced analysis. So think of software for like finite element analysis and computational fluid dynamics. But more than that, we're developing new software tools that can help you interrogate a design and figure out, is it more efficient to make this part with 3D printing, or is it more efficient to make it with subtractive manufacturing? So we're doing lots of research in this area of advanced analysis. Also, intelligent machining. You heard talking about embedding sensors into parts, also embedding sensors into machine tools. Imagine every machine tool in the future on every shop floor in this country, all being connected to the internet, all streaming real-time data to the cloud, really smart people doing advanced analytics and figuring out more efficient ways to machine, predicting when maintenance should be done on those machines. Those are the kinds of research topics we're working on. And last but not least, advanced manufacturing enterprise. Big fancy name that the US government came up with, pretty much encompasses everything. But think about the digital thread. You heard mention of the digital twin. So all the zeros and ones, all the bits and bytes that make up those designs flowing seamlessly through the entire manufacturing process, up and down the entire supply chain. All 3 of these technology thrust areas are areas that we're doing research in. We've got over $40 million worth of research projects underway already. We've got another $40 million of research projects that are in the pipeline. And any of you can get involved with this. We made our tiered membership model very attractive for small, medium companies. So all you have to do is go to our website, check it out, look at the research projects that are going on, see if you're interested. If you want to come to a workshop at DMDII, you are welcome. You do not have to be a member to come to our workshops. If you want to even submit a proposal, you do not have to be a member to submit a proposal. If your proposal gets selected, you have to be a member. But guess what? It's only $500 a year to be a member. So we welcome you, and I can tell you that this idea of intelligent design, smart manufacturing, and what HP is doing, I mean, we want to be right in the middle of that on the design side. So we're digital manufacturing and design. So we partner with America Makes. We would like to be able to help on the design side of 3D printing and be able to make this whole process more efficient. So welcome you to join, or at least check us out, and look forward to meeting you. Thank you very much.
So good morning. So I don't know if you know, but I don't think we were supposed to take the podium, but Dean's a little bit like a bull in a china shop, so now we'll all take the podium. John Vickers from NASA, and I'm just the advanced manufacturing guy at NASA. So this is about as cool as it gets. I'm going to talk to, it's about as cool as it gets for me. I'm going to talk to Debbie and see if we can't do this for 2 weeks next year. It is my first time to Rapid, I'm sorry to say, after seeing what I saw here yesterday and again today. Everybody's so high energy speaker, and NASA's John Vickers is a description that usually doesn't go together. But I'll do my best. I promise I'll do my best. The theme of our discussion today was the digital thread and digital twin and factory of the future, and so on my way to the conference, I put together this really nice speech, but after hearing what I heard yesterday and after hearing what we heard today, I think I'll throw all of that out because it doesn't quite fit, and I'm going to ad lib. So forgive me, I'll ad lib a little bit. But in association with the digital thread and digital twin, there's a couple of connections that I think we should make. And one of those is technology and fusion. We see all of this great technology from 3D printing and rapid prototyping. And by the way, we've been in that business at NASA for about 25 years. And we have a very significant effort there today. But what we're trying to do with digital manufacturing and 3D printing as a part of digital manufacturing for us is make our products, make our missions more affordable, and give them more capability or more performance. So money and speed, that's two pretty cool things to be associated with, right? And then the other thing I'll talk about a little bit, and maybe we can get some questions on, is the ecosystem. And I heard about some of that yesterday. So we're really, I think the way that we advance this technology best, and it's hard to slow this group down, I was going to talk about accelerating technology, but from what I heard yesterday, the pace is so fast, it is so quick coming out of this community that I hesitate to say anything to slow it down. And I'll make a comment about something that I heard at the panel discussion yesterday, and I was right with the answer that the panelists gave until I heard some more about what was going on at this conference. And so I think I'm going to revisit my position, and so if we get a question on that, I'll talk about that as well. But back to the ecosystem, I think the best way for us to accelerate technology, although like I said, it's going pretty fast here, is to work across lines. So we work across design, we work across materials, we work across manufacturing, we work across industrial sectors, and for me, we work across technology readiness levels. So we work at the basic research, we work at development, at engineering, and at production level. So I hope we get to talk about some of those things today. Thank you for having me.
Do you want 5 more minutes? First of all, I would really be interested to hear from all of you, and especially just what are some of the things, Steve, that you see in terms of maybe a connection between digital and space and maybe some of the technology that HP is putting out right now?
Digital and space.
Yeah, space.
I think when I think about the connection between digital and space and just digital and industry in general, I think there is this mega trend. And the mega trend is digitization. I mean, all industries are getting digital. You see it in space, you see it in automotive, you see it in banking. I mean, there isn't one industry that's not going digital. So, you know, I think every industry needs, right now, is taking a step back and thinking about how do I embrace digital? What does it mean to me? And I think what's interesting when you get into 3D printing or additive manufacturing, it naturally is based on ones and zeros. And so now all of a sudden when you think about, you start with ones and zeros, you can go through the whole process, build with ones and zeros, and ultimately, and you'll be able to see this if you go to the HP Voxel lab, you'll be able to see we can assign every single part a unique identity, every part ever built. And now all of a sudden you can close a loop. And you can all of a sudden say, now I have this digital thread going all the way through my part, I close a loop. And that will be applicable to space. It'll be applicable to just about every industry. So now intelligence, I mean, then it gets crazy, right? When you start being able to print and manipulate at the voxel level, then it gets kind of just crazy what you can do. And what is going to be really challenging for all industries is to take a step back and think differently. Because you cannot, it's going to be hard to think like the balance has changed. I got to think differently. I got to design differently. And again, it's going to be true for space. It'll be true for everything. So I think it's so changing end to end, and it's just going to be how you rethink just everything.
Rethinking everything. You guys ready for that? Mm-hmm. Rethink everything? John Vickers said he rethought his whole presentation, so I guess we're making some changes here at Rapid. Dean, how do you see additive being a technology that's well positioned for that digital integration, the digital thread?
Well, you know, the whole time I was thinking about your connection with space, and of course, I think it's appropriate for the 300-pound guy to think about lightweighting, because my friend Ralph continues to tell me how much advancements we're going to make in lightweighting all kinds of designs, because you can design these things for 3D printing uniquely in such a way that you can never design things before, and you can take significant weight out of parts and still have the same strength and all the other properties you're looking for. So the ability to do that is going to revolutionize manufacturing, and it's going to make aircraft going to space a heck of a lot lighter, which everyone is interested in, and I'm sure John could talk to that much more intelligently than I can. But yeah, I think that's very exciting. And the area that we want to focus on at DMDII related to this is how can we train up the future designers to be able to take advantage of these technologies, because current designers have always sort of done it a certain way, but these technologies for 3D printing are changing that so rapidly. Notice I got rapidly in there, Debbie?
Yeah, good job.
That it's going to be pretty exciting to think of new ways and develop new systems in order to enable designers to make these parts in such a way that you take advantage of the technology and make them lighter and stronger, et cetera, and then to embed the smart technologies into them at the same time. Man, it's exciting times.
That's awesome. John, talk a little bit about that lightweighting idea as it relates to space. They always say it's tons in ships and pounds in planes and ounces in space. How does that work?
Yeah, so I thought I wasn't going to get to answer the space question, but I'm really glad I did. So I mentioned in my opening remarks, we're really interested in affordability and performance, and sometimes we can get both those things at the same time, but other times we have to trade one against another. We like to say that we're after half the weight at half the cost at twice the speed.
Okay.
And that's really true for NASA, because we heard Stephen talk about getting products at half the cost, and so our products really our aerospace and space products really cost too much and take too long today. So we're trying to drive that down. But at NASA, we're looking at two areas for digital manufacturing and for 3D printing, and that's either for space, liquid rocket engines, for example, or in space. And so for the liquid rocket engine, we're trying to reduce the cost. The cost of those engines today are tens of millions of dollars. And so we really need to reduce the cost in half. And we can do that. Some of those components for liquid rocket engines have 300 individual pieces today made by conventional manufacturing processes and take 6 months to a year to build. And so we can reduce the number of parts from 300 in some cases to a half a dozen, right? And reduce the time to build from a year to 3 months, for example, something like that. So that's a tremendous affordability gain for us. And the in-space applications for digital manufacturing and 3D printing, we don't even know all of those, but we're trying to, we have a 3D printer. We put a 3D printer up in late 2014 on the International Space Station. We've just delivered, and so it's been in operation. We've just delivered another 3D printer. The first one was for research and development. The new 3D printer that's more robust, more capable, that was just delivered a month or so ago to the International Space Station. We're going to use that together with commercial industries to make new discoveries. But really, our goal we're on a long-term journey to Mars at NASA, and so our goal for in-space manufacturing and the use of digital manufacturing and 3D printing is to be able to not take all the supplies with us. So build the supplies that we need, repair the parts that break. So in-space fabrication and repair is a term that we use.
That's great. I guess you don't see too many UPS trucks up in space, do you?
No.
No.
So not on the way to Mars. In low Earth orbit, maybe. We can send up resupplies.
Okay.
But not if we're on the way to the moon or to Mars. No UPS.
That's great.
Although I do hear they're in 3D printing today.
I've heard that too. How many of you have actually seen Jason Dunn and seen the 3D printing in space? Fascinating. I I would recommend it to you to kind of look into that. He's spoken for us before in the past, and really exciting to think that you're shipping electrons, right, and not things. So that's really great. I did get an interesting question, so I'm just going to assume that this person is not alone. Dean, explain to us the digital thread for just a minute. Someone said, what is that?
The digital thread?
Yeah.
Yeah, so when you are designing a product, you're using computer-aided design software, you're looking at the computer monitor, and you're making decisions. You're making decisions about features, you're making decisions about material choices, and all of that is represented on that computer screen based on the zeros and ones that the computers use, all the bits and bytes, to portray that image. But that data that represents that virtual design is extremely important data. So when you are 3D printing, once you have that design, you just push a button, and it goes right to the 3D printer. So we want to be able to do that same thing with subtractive manufacturing. We would love to be able to push a button and have the machines automatically take all that intelligent data from that computer design software and immediately begin to manufacture parts. So there's a few steps in between that we have to do right now, but eventually we want to get to that. So think about those zeros and ones. If you can imagine them, every time you see a PowerPoint slide from anybody that's doing a presentation on digital manufacturing, you'll see these zeros and ones, like flowing through some kind of a pipe, right? Some kind of fiber optic cable, right? So think about that data flowing seamlessly through that entire manufacturing process. And then as you're producing those parts, you're also learning more and more about how that part was made. That's additional intelligence about that part that you're gathering along the process. By the time that individual product, that one unit, rolls off the production line, you have a tremendous amount of information of how that part was designed and how that part was produced. That's the digital thread. And even once it gets out into the marketplace and it's used, there's even more data that's being generated on a lot of the different types of products. I mean, General Electric, for example, tracks so much data from their engines, and that data comes back, and what do they use it for? They use it to figure out what things are going on when those products are being used, and how can they make changes to design those products in the future to be even better. That's the entire digital thread, all the way through to end of life. And what do you do with that product at the end of life? What's the safest way to get rid of the materials or reuse those materials preferably? All of that is the digital thread, and we want it flowing up and down the entire supply chain through that entire design and manufacture process.
Thank you. One question about materials. I know there were different colors of parts here on the platform. Can you talk a little bit about the different types of materials that are going to be processed there?
Yeah, so again, what was on the platform was examples of the black part gears were the multi-jet fusion, and we were showing a compare versus the other printing technologies and what you can produce in the same given amount of time. Multi-jet fusion is a process that works with plastics, or you think of thermoplastics, and so what you'll see from us is when we introduce, we'll be introducing with PA 12 or nylon 12 11s, and then we have a roadmap, and we've shared this, where we'll be at additives, glass, fire retardant, we'll go to new families, elastomers, and whatnot. And what we're really counting on is, with our open platform, is with the material partners to be able to get a hold of our systems and just dramatically expand those materials. So we feel like we have a great process. It's basically multi-jet fusion. If it's plastic, we're going to be able to process it in one form or the other. Now, we also, and again, I'm kind of pitching the HP Voxel Lab a lot, but it's very cool. We actually have in there some, we've demonstrated, we talked about, we have in there with a variation of multi-jet fusion ceramic. So we're able to produce very high resolution, high density ceramic parts as well. Very early stage, and this is an example of, we just want to show people what we're doing. On that particular one, we don't have a hard plan to bring it to the market. We're actually using this forum to expose it, and again, say to the world, hey, if you think this is interesting, that if you can do something with a high resolution, high density ceramic part, talk to us. Maybe there's something to be done there. Because actually when you do a market study on something like that, which we've done, since the world really can't produce high resolution, high density ceramic parts today, you really don't find the applications. So it's kind of a chicken and egg thing.
Okay, great. John, I have a question here from the audience, and I think you might be able to help us here. How far away do you think we are from having some standards for flight-critical parts in additive?
Sure, that's the technology infusion part that I talked about. What we're really interested in is how these parts and hardware behave when you consider as designed versus as manufactured. And the digital twin or the digital thread can help us with that a lot. There's an awful lot of analysis that goes in, especially the complex aerospace parts, human-rated aerospace parts, whether they're for commercial aviation or whether they're for space. Those are really critical that we understand that they behave as they're intended to behave. And so in the aerospace industry, we go through what we call the building block approach. And so we do today, that's very empirical. It's supported by analysis, but we don't rely on the analysis. We rely on the behavior of the physical parts. So we do all kinds of mechanical properties. That's what leads to, in many cases, to the extremely high cost. And so we're trying to use the digital thread and the digital twin concepts to do more than just support the physical testing that we do. So that's what I would say, and that's how we're going to infuse today. We don't have any 3D printed parts that are human rated for our liquid rocket engines. We may have those in non-highly loaded structures, but we don't have any. And I'm not that familiar with what goes on in the FAA or the commercial aviation, but I think there's very few. So that's one of the things that we need to do to accelerate the technology into these specific industrial sectors, is to make that qualification process much quicker and make it rely on analysis rather than these hundreds of thousands and millions of dollars of expensive physical tests.
Great. This is a good question, Dean. I'm going to let you kind of chirp in on this one, or actually any of you could. How do you address the kind of the design side of additive manufacturing to fully take advantage of the capabilities of some of this new technology we've got in 3D printing?
Yeah, it's a great question. So that's some of the projects that we've launched in DMDII, is to look at how we can use some of these advanced technologies to determine, first of all, is the best way to make a certain part with 3D printing, or is it better to make it with traditional subtractive manufacturing? So we're developing expert systems, software programs that will interrogate different design concepts and be able to make recommendations, maybe on a scale of 1 to 10. It's higher probability to make it with 3D printing than it is depending on, of course, the end product parameters, right? How strong it has to be, how light it has to be, how cost effective it has to be. We want those expert systems to have all those variables so that when a designer is trying to decide how to design this product, what's the best way to make the product, all going on at the same time. So keep an eye on the projects that are evolving out of DMDI on our website. You'll be able to touch into some of those projects and figure out maybe there's other ideas that you have that we're not thinking of currently, or the researchers aren't thinking of currently, and that yields to great opportunities for each of you to propose a project and do more research in this area. It's an emerging area that I think is pretty exciting. I don't think anyone really has a firm answer yet on exactly how to do it.
Yes.
So, well, that's a big topic. And as we talk about how do you change how people design and manufacture, one of the things that has become very clear to us is, first off, again, I'm going to just reiterate, we want to be totally open. If we're going to get this industry really to accelerate, it's going to happen by people just jumping and innovating. And specifically for us, one of the kind of the interesting dilemmas for us is, as we're a voxel level 3D printing technology, which is pretty unique. How do you design at the voxel level? How do you design? Do you go in there and it's ones and zeros at that level of like assembly code? You have to abstract it. So what you're really seeing is these are where you need new tools. And one of the things we did announce, only had 15 minutes, couldn't go into all, but you'll be able to see in the booth. We announced a partnership with Siemens PLM. And so one of the things when we talked to Siemens, we said it needs new design tools. So you have to not only be able to design at a certain level, bring it down to, and be able to describe it at that voxel level, be able to simulate it, and then of course you have to be able to then kind of translate it to where you actually produce it. So what we're doing with Siemens is we're going to have a roadmap of new voxel level capabilities. And so what Siemens will be doing is looking at their design tools. They announced this yesterday, and they will be building capabilities in so you can take advantage of that capability that we have in multi-jet fusion. And it's not, now you can design and you can simulate it. Now the other thing is you'll go in, and it's very interesting, and this is we just have to get going as an industry. We have kind of some interesting color parts. Now our first product is monochrome, right? We make it's black parts. We have color that will be coming out. When you get color at the voxel level, how do you describe it? It doesn't exist. That standard doesn't exist. Now again, that's why we're advocating for 3MF, because that will then integrate how you describe color. Nobody should try and own that. That should be just available for the industry, and then others can innovate on top of it. So there's just so much that has to go end to end, and we have to get the experts in those areas doing what they do well, all driving off this vision, all driving ultimately down to enabling the voxel level, and that's just going to accelerate for certainly high performance industries like space, but this needs to get everywhere, right? Every device you have, consumer product goods, automotive, et cetera.
That's great. John, any comments on
Sure, I'll
design?
make a couple of comments. I'll try to tie it back to the comments that I heard in the panel discussion yesterday that left me thinking a little bit. So we all have cultural biases. So what we need in these design organizations is someone that doesn't have those cultural biases, that says when we go to design a new part for our spacecraft or our rocket engine, that immediately thinks, how do we build this by conventional methods? We need somebody in that organization that says, no, how do we build this with the new technology, rapid prototyping, 3D printing. So the question that I heard yesterday in the panel was, will additive manufacturing take over all traditional manufacturing? And unanimously and quickly I saw the audience, and I felt it myself, say, no, that's not really possible. But I don't know. You know, I'm not sure we're thinking far enough ahead. Maybe it will, but I'll give an example. I was in a meeting just a couple of weeks ago at NASA, and it wasn't about 3D printing, because there's really some cultural bias against introducing new technology in very high risk endeavors like we take on at NASA. And this one was about composites, and we were just, because I am the advanced manufacturing guy, so it's not only, I'm not the additive expert, I'm sort of the technology advanced manufacturing guy. So we were talking about composites, and I was in the meeting, and we were talking about composites for a very new spacecraft, one that might go to Mars, and one of the senior guys stands up, an old guy if that's not politically incorrect, and said, and so he said, you know, I think composites really is a stretch too far for human-rated pressurized spacecraft. And so you saw some of the younger guys just like deflate, right? Because we've got to, we're trying to get to that affordability and extremely high performance, you know, half the weight and half the cost at twice the speed. And it's a lot of times it's the cultural bias that we all have, you know, from either our age or our experience that holds us back from that. So
that's great. We're all ready to think differently, right? That's what we heard. We're going to think differently. So got to change that mindset. That's fantastic.
Yeah, so this group has really spurred me to go back and think a little differently myself.
That's awesome.
I'm one of the old guys. Right?
You've inspired space exploration today, so that's fantastic.
I don't know when that happened, but
I want to address one topic that I think cuts across all of this that you mentioned in your presentation about the cloud. We talk about, you know, cloud-based things, you know, larger systems. What about cybersecurity? How much of an issue is that? How do we address that? It's kind of in the back of everyone's minds when we talk about digital threat and open systems and things like that. Stephen, you want to address that one?
Again, another big topic. So first off, we're certainly advocating kind of cloud, and we're going to be very much embracing that as a mega trend. I actually think the cloud is one of the keys to this industry. Because again, when you think about getting down to the voxel level, the amount of compute, the amount of store that you need to really take advantage of what's possible, that's what's great about the cloud. You can get almost infinite compute, infinite store for a low price. So I think that's a kind of an enabler for the industry. So I think it's just really, again, kind of making sure we're leaning into it. I think as an industry, we just need to be leaning into the cloud, and we certainly are. You know, our devices will be cloud connected. They're going to, you talk about the digital thread, we won't be watching what people are printing, but we'll be able to get information back, and that will let us refine kind of the process as well. Now, the issue of security, cybersecurity, wow. Now, the good thing, it's a little bit of an HP pitch, I mean, that's something we do well. We definitely have the most secure printers on the world, and anything on the network is something, and so we're very aware of that, and it'll be a strength of our products for sure. But the other element of it, and what I've really kind of grown to appreciate if we talk about learning the industry, is, of course, in 2D printing, which is where I spent most of my career, we thought we had these problems licked, right? Security of your documents, whatnot. And when we've gotten into this industry, what I've observed is people are even that much more concerned about the security of their content for good reasons. So again, I think you have to go to the cloud. You're going to have to put the security in there, make sure your device is secured. It's a trend, and that's just, you know, that's what technology does. It's going to solve those problems.
That's great. Dean?
Yeah, so cybersecurity is a really, really hot topic amongst the members of DMDII. You know, we have about 14 really large corporations that contribute significant membership fees, and all of them are very concerned. When I tool around the country, which I do quite a bit, and I meet a lot of small medium manufacturers, and I try to give the pitch about moving towards digital manufacturing and design technologies. When I mentioned, like I did in my earlier talk, that we want to connect every machine tool in every shop floor in the country to the internet, you know, these individual small shop owners say, you want to do what? So it's a big concern, because as soon as you think about connecting your machine tools to the internet, you immediately think about people hacking your machine tools, stealing your proprietary information, your process know-how, and even worse, causing your machine tools to do things that you don't want them to do. So it's a huge concern, and there's a tremendous amount of research going on in the area of cybersecurity, not so much in the area of cybersecurity specifically for advanced manufacturing. So how do we protect the SCADA systems, the PLCs, the machine controllers? How do we make sure that all these sensors we want to put on machine tools to be able to stream data to the cloud and back, how do we make sure that all of that is secure? That no one's going to come in and steal your stuff or cause your machine to do something? So it's a huge concern, so much so that we are advocating very strongly to the U.S. government right now that this topic of cybersecurity for advanced manufacturing should be the topic of one of their new institutes. They're going to do 6 more institutes in the next 12 months, and they're currently in evaluations of determining what topics to choose. And there's some really good topics out there, but we're advocating very strongly that they should have a separate institute only for cybersecurity for advanced manufacturing, because there's so much research that needs to be done.
John, any comments on cybersecurity?
Well, I always make a comment. It's not really my area, so I don't have the bandwidth really to deal with that too much, so I leave it to the experts. But it is an issue. So in my industry, most of the information, a lot of the information, a lot of the technology is regulated for export control. It can't go to non-U.S. Entities and citizens, and so that makes this. You know, in the past, what we would do with everything was produced in 2D on paper. We'd stamp it. It would be stamped classified. It would be stamped sensitive. It would go into a locked file cabinet. So, hey, you know, we're all good. But it is an issue for us. In fact, just 2 weeks ago, we had our security information agents come down, and we explained to them what we were doing with digital manufacturing and 3D printing. And my request to them, and so I came over and listened. My request to them was, we don't understand it, and so that's why they're coming down to try to better understand it. My request to them was, try not to slow us down too much with undue regulation. But there is an issue. There's good reason that we regulate some of this proprietary or classified type information, and so we've got to protect it, but I'm not the guy. I don't know how we do that. So sorry.
All right, fair enough. I know we have a lot of small and medium-sized companies here at Rapid. You know, a lot of companies see this as a really, additive manufacturing is a great tool for innovating design and things like that. How do small and medium-sized companies address all this data? Data from their customers, data from their suppliers. You're kind of a link in the chain. Dean, how do you see them really making the most of digital manufacturing data?
Yeah, so we're working on a sort of a how-to manual to get involved in starting your journey for digital manufacturing and design. So we don't have all those answers yet. We've got some really smart people working on that. But that's a question I get from small mediums all the time. And one of the reasons we made our membership fee for small mediums only $500 is so they can get involved with what's going on at the Institute. They can see the research that's going on. They can come to the program management reviews and get detailed information about each one of these projects that have been awarded and begin to figure out for themselves, how can we start this journey? You can add sensors to an existing machine tool and stream a whole lot of data to the cloud. But how do what do you do with that data? I hear all the time that some companies, some of the larger companies like GE, streaming tons and tons of data off their machine tools, not doing too much with it yet. So there's still a lot to be done in this area of figuring out what to do with the data, building that data lake, but eventually we're going to have that data lake. We're going to be able to have these really smart guys do the kind of analytics that we're expecting to be done and be able to provide information back to the small mediums on, you can change that bearing on third shift instead of interrupting your first shift production because it's going to fail next week. That's the kind of intelligence we think we're going to get from this data, and it's fairly affordable to start that journey. Before I left General Dynamics, we installed a data collection box that covered 6 different CNC lathes and started streaming data for a lousy $2,000. So you don't have to buy all new machine tools, although some of the new machine tools are coming out are pretty cool. But you don't have to buy all new machine tools. You can retrofit your legacy machine tools for a very modest amount of money with sensors and begin to stream that data. And there are companies already popping up out there that have applications on how to use that data and provide intelligence back to you to make your manufacturing process more efficient.
Great. Any thoughts for small, medium-sized companies, John? In this
Sure, and I should have included them in the ecosystem that I talked about in my opening remarks. Across small, medium, large businesses, if you saw the video in the introduction, the rocket that was launching is our new space launch. It was an artist animation of our new space launch system. It's a real rocket so it's a physical rocket that will launch in 2018. I just heard recently that we have over 1,000, so well over 1,000 businesses that contribute to the production of that rocket that we're going to launch in 2018. Not just NASA, but I think it's pervasive in most industries. Some do better than others. We're poorly connected. We're poorly interoperable. Everybody's producing digital information. Every one of those companies is producing the information that they produce is in a digital form, but it's not interconnected, it's not interoperable, it doesn't travel well back and forth up the chains. Sometimes I say we have digital devices and we have analog thinking, right? And so I think that's true more with small business than it is with any other class of business. And so that's something I think if we're really going to reach this half the cost affordability, that might be the biggest thing for us to work on. And the guys like Ed and Dean and the NNMI, that's part of the thinking behind NNMI, and that's maybe one of the greatest opportunities that we have in this nation to support small business is what we're doing in a collective way is to support the NNMI. So call your congressman.
Great. Stephen, thoughts for small and medium businesses?
Yeah, so I'll try and draw an analogy. And I'll connect with the 3D. So we sell, for instance, we have a graphics business that we created in 2005. And so what we're doing is we're selling, in this case, digital printing devices, 2D, not 3D, selling them to typically small family-run businesses. These presses will run anywhere from 500,000 to $1 million, $1.5 million. These families, so they're buying these presses. These presses are their factories. And so what we've done over time is these presses it's kind of get back to, they're connected, they're giving us data. And so what we're able to do when you get your device connected and that small business family running, what we actually do is we get their data from how they're operating and we share back with them how they're doing. And they actually can go and they get a daily report card. It's like, here's how you're performing relative to everybody else in the world. So they can see it's the same press, so there's these presses around the world, and they actually can see, and then they can say like, wow, my uptime I'm like in the bottom 10%. I don't want to be in the bottom 10%. I want to be in the top 10%. So then they come to us, and we can work with them. So I think so I'm giving you an analogy, but it's real. And I think that's exactly and that's what we plan to do certainly in 3D, is we want to get our devices connected, get the data back, and this is the beautiful thing about big data. Now you have to figure out how to do something with the data. You get it back, you start learning. And I think for small businesses, they're going to be able to learn, and it's up to us to help them, because make them more productive, because they can't do it on their own. There's just no way.
That's great. That's great. I'm going to give you guys just a couple minutes for some final thoughts. We just have a few minutes left here. Final thoughts on digital, additive, how it all fits together. What's the future look like?
Well, I gotta say hats off to HP. I mean, wow. So I'm very excited for what the future holds for this technology. Would love, of course, self-promotion here, would love to have HP take a hard look at DMDII. Because some of the challenges you just talked about, Steve, I mean, Siemens, PLM, they're a partner with us. Would love to figure out how we could leverage that along with America Makes. We could do some, I'm sure Ralph's going to say amen to this, we could do a couple of cooperative projects together with America Makes, where we focus on the design side, and America Makes focus on the production side. There's lots of opportunities to leverage that investment that the U.S. government's putting into these institutes and be able to help the entire community. So very, very exciting, and I'm coming down to the booth as soon as we're done. I want to check this thing out.
That's awesome. John?
Yeah, same here. I can't wait to get down to the show floor and see what's going on down there. And I like the idea of cooperation. It's this, and I'm the same way. Ever since I've arrived, I've just been sort of wild, and the smoke's coming out of my ears and that kind of thing. But it's this community with digital manufacturing. I think digital manufacturing, and that's all the digital thread and digital twin and 3D printing, all those things together, is the single greatest opportunity for us in this nation to improve our competitiveness, and for me in my industry to reduce the cost and improve performance. And it's this group here that I think that is taking what a lot of, due to cultural biases, we think that it's exotic technology. You guys are making that routine for us, and same for HP.
Thank you. Okay, how would I close this? So I'll say today 3D printing, people look at it and they see what it can do in terms of kind of amazing examples, and high performance is definitely an area, things like aerospace. I think the real opportunity for us is to take that and have it go through industries, all industries. And I think it's really a challenge for us to think about, and that's what we want to work on, is how do we take it from being kind of this really high performance application, have it be an application across all industries. It's not, will the world all go digital manufacturing one day? The answer is yes. It's not hard to predict the future. It's hard to predict when, right? But it's going to happen. And I think the only way it's going to happen is through continued innovation. And there's no one company who's going to be able to own that. And I'll go back to, if we can grow that pie, everybody wins. And that certainly is our position. And I think as an industry, we kind of just take this approach to let's grow the pie, let's go mainstream. Everybody's going to be better off.
Awesome. Thanks so much. Please join me in thanking our panelists.